Well guys, welcome to today's video. Today we are going to discuss a very important section on load balancing. So load balancing is a very important concept that is generally asked in system design interview questions a lot of times, and you need to understand what is load balancing, what are the different components, how does it work out, how do you put in your designs. So without wasting any time, let's just quickly start. And before we continue, if you are coming here for the first time, I'll request you to subscribe to the channel so you don't miss any of the upcoming content. And we start now. So today we shall be covering what are the basics of load balancing, what is a load balancer, why do we need it. We will try to understand that with a few scenarios. Then we shall move into the types of load balancer, DNS, L4, L7. And lastly, we will try to see where to use what along with the differences between the L4 and the L7. Alright, so let's begin. So we shall first start with the basic concepts, and I'll quickly move to my whiteboard for this, which is right here. So what you see on screen is basically, it's a very simple system. Let's say you are going to a government office. Now there is a counter over here that people can visit, and there are a lot of users over here that want to actually go inside. Now what will happen? Let's say the counter is open, so the first person comes in and he will wait over here. Then the second person comes in. Basically all the people that are available, that will queue up. Now if the rush is less, it can be actually very easily handled, but if it takes a longer time due to whatever reason for handling of like resolving the queries of this user, it will actually take a lot of time and the queue will start piling up. So let's say these three users move up, this user goes out, and then a few more users joining in between. So this queue will end up so we will end up having more and more users, and the queue will get larger. Well, the simplest solution that comes up is, why can't we just increase these counters? Okay, let me just do that. Now we have three counters over here that have different capacity. Now, assuming these all are separate counters, as in like modern stateless system, which we shall cover shortly, they don't see, actually they can't see, and neither the users can't see which server has maximum load. And what will happen, they will just, let's say, go up over here and start queuing up. Let's say three users go over here. Now some users might also go to others as well, but considering a practical use case, let's say all of the users are on the same counter. Now this is a very let's say if the walls are big, users can't see what's inside, so this can be a very practical scenario. Now we do have these counters over here where the users can actually go, but the problem is we need a mechanism that can direct these users from here to here, so that the load is equally distributed. Let's say over there, and some of the users over there. So we need a mechanism, and the best way we can do that, that's also actually pretty easy. Alright, so what we can do basically is we have kept a receptionist over here, and what this receptionist does is basically just redirect the user depending upon the availability. Now assuming this receptionist has some mechanism to distribute the load easily, and there are different approaches which we shall cover shortly. So what this can do, the user will first come to a receptionist, and the receptionist will direct her to counter 1. Let's say the next user comes and the receptionist will direct to counter 2, and the next one to counter 3, and that way she can actually distribute all of these users across different counters. Alright, that's pretty cool. Now if we see, the load is relatively easier to manage, and probably what we see over here, the user's turnaround time could be much less, and each of them could be relieved a lot easier. Now, this is the very basic load balancing technique that is happening over here, and receptionist is just distributing the load across counters. Now, what if we want to further improvise it? How can we do that? Well, some of the users are for specific areas, let's say, and what we can do, let's say some of the users are revisiting for whatever purpose, or let's say they have work for electricity department, or they want to do some zone conversion around that, like what a speciality the counters serve, and based on that they can target the users to specific counters. So let's say two users are here for electricity work, then two or one user is here for zoning, and third is for some permits over here. So that way, this receptionist can very easily manage these users across different work. Now, in the previous case that we have just seen, what would happen? Let's say the users are redirected over here, but let's say this user is here for some permit. Alright, so let's assume when the user goes to counter 1 for permit, when it goes over here, the counter 1 sees that it doesn't have this data for the user in its RAT, and the person sitting over here has to go manually to my count 3, and from there it needs to fetch those files, and once the files are fetched, then only it can serve. Now, this is also a possible operation, but it will take some time, and it could have been much faster for both the user and the server as well, in case the user is directly moved to counter 3. Well, that's the next case that we are just seeing over here, and this can be more efficiently managed. So if the receptionist already knows what user is coming into a system, she can very easily direct these users to the relevant counters. Let's say if the data of this user is at counter number 1, the receptionist can directly redirect the user to counter 1. And if there's another user that comes over here that has some work related to electricity, so the receptionist can easily redirect her to counter number 2. So that way the system can be more managed, and this can actually happen if we scale it out. So if we see over here, we have a scaled out version of a system where we have different departments and each of them having different counters. So, and there is a receptionist over here. So this receptionist is basically responsible for redirecting all the users. So whenever a user comes in, those receptionists, she checks like what's the purpose, which department it is, and additionally she has access and can also redistribute the load within each department so that the load is shared equally. So that can be a very optimized system. So what we see over here, so this is basically a load balancing. There is a system application, whatever it is that is running, that basically distributes the load across my given nodes. There can be certain factors on which it redirects them, routes them, or distributes the load. So we shall be covering those. So, but the idea is more or less around this. So when we want to consider basically like what are the different types of load balancers, these are the three prominent types that we use. DNS is the primary one, that is sort of an entry point, the first point of contact. Now there are two different type of approaches around that. One is your round robin and AnyCast. We shall be discussing that shortly. Then we have L4 load balancer and L7 load balancer. Alright, so a quick piece of advice before we move forward. System design is somewhat but not that much complex as that of a rocket science. If you understand the basics, then it's very easy. You just need to understand what components sit over where and you can build up a complete system. So each of the section that we are going to discuss is very, very important. So if you are building any system, load balancing is a very important aspect. You have to build it. There are a lot of things that goes along with it. So don't miss out any of the section. Watch the video till the end to understand these concepts. Let's move forward. So the first part that we are going to see is DNS based load balancing. And to understand the round robin based approach, I'll quickly move back to my diagram. Alright, so what we have over here is I have a DNS server that is serving a domain tech.letsdocoding.com, and there are different machines or application servers that are running and that can serve these requests. So these servers, if you see over here, so they can all receive these requests and handle them, and we have them to handle increased loads. The responsibility of the DNS server, the primary responsibility or the first level of load balancing, as we say it does, is basically round robin. So what happens whenever the first user that puts in a request over here, let's say this is a user and it comes to the DNS server and asks for like what's the IP address of this domain. For the first request, it will return the IP address of this server. Then let's say a new user comes up, that user will be returned the IP address of this server, and likewise this server, and likewise this server. So user doesn't need to know, the servers doesn't need to know. It's a basic funda of the DNS. It rotates these requests in a sort of a round robin way. Now one thing to note over here is that let's say a user requests for an IP address from the DNS server and it receives the address of 100.111.120.17. Now user will not request this IP address again till the time TTL is expired. Now TTL is time to live, or you can also consider this as a sort of a cache timing, and till the time that cache is not expired, the user will use the cached IP address. So let's say if I have my cache timing of 30 minutes. So within that time, if the user or the client needs to send or go to that host name again, it will just reuse that IP address. It will not query the DNS server. So let me just quickly show you as well how these things actually work, and this is pretty easy. So I'm having a Windows machine and there's a command called nslookup. So this gives me the default DNS server that I am currently using, which is my local machine over here, if you see. Now let's say I want to know what's the IP addresses configured for this particular domain. So let me just do that. So the default configuration over here is a record, and if I query this DNS server for this domain, it should return me all the IP addresses that are configured for it. If you see, there are two IP addresses over here that are configured to work, and we can just try to see. And if we try to ping, let's say the domain name, we will connect to one of these IP addresses. Now if I do that again, because there is a timeout that is configured, and within that timeout, within the TTL, if we hit that request again, it will basically go to the same IP address. Once that time is expired, then it will go to a different IP address. So that is one. How does the DNS round robin approach work? So basically, if we try to map, let's say if there are 4 servers and there are multiple requests coming in, so the red block that you see, those would be the IP addresses that is returned. For the first request, it would be server 1, then 2, then 3, then 4. Then again, it will start repeating 1, 2, 3, 4, 1 in lightweight fashion. So that is round robin. Apart from that, we also use DNS servers for our different approach, where the machines are actually across different geographies. So this is more of a practical use case around CDN or content delivery networks, where you want to achieve faster connections. And this is also a very common use case with your cloud providers. So this is highlighted over here if you see, and this is basically a DNS AnyCast approach. And what happens over here, again I am here showing a Route 53 based DNS server. It could be anything. So there's a Cloudflare, there are different, you can use a lot of these similar services that provide AnyCast addresses. Well, AnyCast address is an address that can be routed via different routes. For example, let's say if we get an address of 1.2.3.4. Now, if a user who's in UK, he tries to visit, he will get a different route. And if a user who's in Japan, he will get a different route to the servers. So whatever the best possible and least latency route, that route will be selected and the user can visit that. If I have my application distributed across regions, deployed across regions, let's say US East, West, APAC, and EU East, in those cases, my single IP address, the Anycast IP that I configure, based on the user's location, user can directly go to the nearest zone. If a user is in US East, he will go to this server, and if the user is in India or APAC region, he will go to this server. Likewise for your US East and US West. So that way it will happen. So that's pretty much with the DNS based load balancing. Now without wasting any time, let's quickly move to L4 and L7 load balancing. Let's quickly move to L4 and L7 load balancing. Now, before we move forward, let's have a quick review of the OSI model. We must have read this model, studied about it in our college, in education, and this is like pretty much the basics of all the network communications that we see. So in that, we have a layer 4 over here, that is your L4 we also call it, which is basically a transport layer, and we have a L7 or the application layer. Well, if you know about it, I don't need to go into detail, but L4 deals with how to manage the transport between two connections, what protocols to use, and L7 is more of a application based layer where it deals more about the data, the content of the model. So likewise on these two layers, if we apply load balancing on L4, it's called L4 load balancing. And the device that does that is called L4 load balancer. And likewise for the L7, we have a L7 load balancing, and the device is called the L7 load balancer. So in most cases, what you can expect is this can be a dedicated device, generally an appliance that is provided by a vendor with your routers or your networking equipment. And in many cases, the L7 is more of an application that runs on some system. So what is a L4 load balancer? Well, we already have seen it. Let me just quickly open a diagram and you will quickly understand what it is. One second. So if we go over here, yeah, over here. So this is this is my L4 load balancer, and basically what is happening is the receptionist is just round robining the users across counters. So she doesn't see what purpose the user is visiting for. She just sees, okay, you go to counter 1, you go to counter 2, you go to counter 3, and likewise repeating that. So that is basically the L4 load balancer you can consider. So this receptionist can be replaced via L4 load balancer. These can be your application servers, and the users, these could be your individual requests that do come in. So based on the current logic, if we just quickly see like what are the different features of a L4 load balancer, we can consider these as a very bare bone implementation. It doesn't do any advanced or smart routing. It just reads the header of the packet that is coming in, and based on that it just redirects. There is no deep packet inspection, and it's very simple. It just carry and forward. Basically a sort of a NAT is happening over here. Now again, this is sort of a very simple thing, but there are still a few rules that can be applied, and based on which routing can be done to a specific application server. The rules can be controlled based on the protocol, which could be your TCP or UDP. Then there could be your source or destination IP addresses based on which you can redirect, and your ports as well. So on all those bases, you can actually redirect the request to your different servers. Now, if you see over here, these are all L4 specific areas on which we are routing. And as I mentioned, in many cases, the L4 load balancers are basically network appliances, except for cloud. I'm speaking on the on-prem devices. So these are basically, in most cases, vendor-specific implementations and hardware appliances that set up in your networking rack. And I would say the L4 systems are a bit obsolete now in most cases. In most of the current cases, the ideal way is to go for L7, because we will shortly see there are certain benefits of using that. So let's move to L7 load balancer now. Load balancer is also something that we have seen. So if we see over here, we have a receptionist which is very smart, and based on the type of request, this receptionist over here, this can actually redirect user to different counters. So L7 load balancer is targeted for more advanced use cases. It basically helps in doing a lot of things around that. And the first thing that it does is deep packet inspection. It sees like what are the contents of the messages, and based on that, it can take routing decision where the message should actually go. Now there can be multiple parameters based on which you can route, such as source IP, your cookie, your host, header, URL. So there can be a lot of parameters that is a part of a request object, and based on those you can try to see where the request should route. Apart from that, you can also set weighted rules, as in if you want a particular server to handle more requests. So all those sort of options are available with the L7 load balancer. Now, since we are already working with the L7 load balancer, which is a sort of an application layer, and it does provide us access to a lot of request parameters, so we can use a lot of strategies for routing. Some of those are like round robin, weighted response, weighted round robin, and then least connectivity. All those sort of options are there, how much response time a server is taking, and based on that you can take the call and route the request over. So there are a lot of benefits, and one of the very common use case is to use the repackaging of content and SNI handling. SNI handling is your SSL certificate handling based on the host name. Now with the SNI, you can just define a SAN or subject name in the SSL certificate, and it will just work out. You can define health chats, and based on that you can define the routings, how it should work, and there are a lot of logging and monitoring options as well that you can do with that. So alright, so we did cover L4 and L7, but let's just quickly see some differences between them, and that help us identify what could be the probable use cases. So layer 4 load balancing can be considered as a very simple type of load balancing where we want to route based on the IP or port. It does packet by packet relay. There is no deep packet inspection. It's very bare bone over there if you see. But on the other part, contrary to it, the layer 7 load balancing is quite advanced. We can call it a smart load balancing as well, and it can do load balancing and routing based on multiple parameters, cookies, request, URL route, whatever it is. So it basically does the deep packet inspection. It sees what are the contents of the request, and based on those contents, it can additionally modify the behavior of that route. So routing rules can also be based on server latency and those parameters, but again, based on the contents of the request, I can formulate my rules as well. And it helps in maintaining a lot of advanced methods and operations, logging, a lot of things are there which we can do. Now comes the important part. Where should you use L4 load balancer, and where shall you use L7? Well, in any of the scenarios where you are directly communicating over on a port, for example your SSH, right, you make a direct TCP or UDP connections to an application server. Well, those are all the probable candidates for your L4 load balancer. If you are trying to connect over an application, now HTTP is a most common case that we use these days, and most of the cloud and all those sort of workloads, they are built on the top of HTTP and target primarily HTTP. So all those sort of things where any of these application layer details are needed for load balancing, L7 is the preferred approach. And in most cases, you will be fine if you use an L7 load balancer, except for cases like SSH or ICMP or those areas. If you want to if you need to access a raw socket over there. But apart from that, in most cases, L7 can be good and fine. So some examples like, so if you are doing an SSH to a cloud machine, a cloud VM, you are probably doing via L4. And if you're accessing a web application, you're consuming some REST APIs, all those will probably happen using a L7 load balancer. Well guys, I hope you liked it. That's it for today. I think this should be able to help you out with at least some of the concepts or confusion around the load balancers, how to use that, or what exactly it is and where to use that. So this is a very important aspect in terms of a system design interview or discussions or your day-to-day work as well, and you need to choose. Now there are different options that are available from different cloud providers. For example, AWS and Azure have a different set of offerings which are more or less similar, and GCP is a bit different in their offerings over here, and probably because they have a different network topology. Anyways, but more or less the concepts remain same, where the product might change, the SKUs around that might change, but more or less the concepts would remain same. Hope you liked the video. Do let me know in case you have any questions or queries. Just put them in the comments box and I will try to revert them as soon as possible. Thanks for watching. Have a great day.